Hey guys, Mr. Gucci here recording my notes video for section 1.2, chemical reaction. So let's get to it, all right? So we talked in the previous section about how chemistry is going to be real focused on the way that atoms break apart the bonds that connect them to other atoms and form new bonds with other atoms, thus creating new substances. Now, this process where atoms can break old bonds and form new bonds to make new substances, this is called a chemical reaction, right? Any process where atoms change how they are bonded to one another, all right? Again, and this can include atoms bonding to form new compounds, breaking apart into atoms or smaller compounds, or both can happen at the same time. And the old vinegar baking soda chemical reaction is just one example of this. What is happening at the atomic level is the vinegar has a hydrogen atom attached. The baking soda has a sodium atom attached to it, and when you mix them together, those atoms switch places to make some new compounds. All right? Now, why do chemical reactions occur? It's kind of complicated, but in essence, it is this, all right? And it is that atoms, in most cases, like to bond, and some bonds are more stable than others, whereas others are less stable. And so whenever possible, given the circumstances, atoms will remove themselves from those unstable bonds and reform into more stable bonds. Now, it may require a push to get the reaction started, like knocking over one domino, and then the rest follow after that. Okay, now some common triggers that can start a chemical reaction are excess light, heat, or oxygen. These are all things that can get an unwanted chemical reaction started, which, by the way, that's why we preserve food in cans or in the refrigerator. We do, to preserve food, we just limit the amount of oxygen, light, or heat that it's exposed to reduce the chance of those chemicals reactions going off, okay? Now, different substances have different chemical properties. And I request that you watch the video I did where I put two different metals, similar looking metals, into a copper 2 chloride solution. Some of those metals reacted and others did not. That's because different substances have different chemical properties. Now, whereas physical properties are like things that you can observe without destroying a substance, like its color, its taste, its smell, is it magnetic? Chemical properties are specifically those other properties that are only apparent if you destroy something, if you put it through a chemical reaction. So things like, what other substances does it react with? All right, what new things are formed when it reacts, and what triggers the reaction to begin? These are all chemical properties, okay? And again, I request that you watch the video where I dunk different metals into this blue solution and we see which substances have the property of reactivity. Okay? So in a chemical reaction, you always have two groups of substances. You have the reactants. These are the things that you start out with. And then you have the products. These are the things that you end with. Okay, so for example, Alka-Seltzer tablets. You start with a certain compound, and when you drop it into water, it breaks down into another compound and carbon dioxide gas. All right, or let's go. A rusting bicycle. That's an easy one. We've talked about rust. The reactants in the rust chemical reaction are iron and oxygen. They are the reactants because that's what you start with. The product is rust because that is what you end up with. And we're going to talk more about this in the next section. Now, a common misconception is that, when I burn a marshmallow, one of the products is fire. Fire is not a product. Fire is actually not a physical thing. It's not a substance that you are producing. Fire is the result of heat from the chemical reaction getting the ash and gases so hot that it actually gets them to start glowing. So when you're burning something, it's the ash or the gases that are produced that are the products, not the fire itself. And as proof of that, in the bottom video here, I have a Formula One driver who actually is caught on fire. As he's running away, he is on fire. And now you can't see it because the particular thing that's on him that's burning is called methanol, and it burns transparently because the products that it produces, when they get hot, they just don't glow as brightly. So you see everyone running around and scattering. They can feel the fire. They can feel the heat that's given off. They just can't see it. Fire is not a product. It's just the products getting heated up so much that they glow. Okay, so quick check here. Pause the video after I asked this. What were the reactants in this chemical reaction here. The products are rust. What were the reactants? The reactants were iron and oxygen. Okay, you started with iron and oxygen, and the products were rust. Reactants, iron and oxygen. Products were rust. Okay, now here's a problem with chemical reactions, and it's this. Okay, this is all about atoms breaking bonds and forming new bonds. That's what a chemical reaction is. But they are so small, these atoms, that we will never, ever, over the course of this entire class, be able to watch individual atoms bonding and breaking apart. Okay? And so what we have to do is we have to look for alternative evidence. All right, other pieces of indirect evidence that a chemical reaction is occurring. So I'm going to give you some pieces of evidence. I just want you to keep something in mind, though, is that there's always exceptions. All right, so no one piece of evidence is usually going to be good enough to prove that atoms are breaking apart and forming new substances. I want you to look for 2 or better yet 3 pieces of evidence. Okay, so here's the first group of evidences. Okay, new properties appear. Remember, every substance, every combination of atoms has its own properties, its own color, its own taste, all right, its own density. So if you see new colors appearing or new smells appearing, well, then you know what? That's probably because there are new substances that are being created. Very few substances change color. When you see something changing color, that's because something new is being produced. All right, so new colors is a big one, new smells, a new solid or liquid or gas appears. Basically, anytime any one of these physical properties of a substance changes, you've probably had a chemical reaction occur. But especially the color and the smell are the big, are the big ones, all right? So, yeah, that was a chemical reaction right there, guys. All right, so listen, here's the next piece of evidence that chemical reactions have occurred, all right? And that is that when atoms form or break bonds, they usually release energy, all right? Which means, and sometimes, occasionally they absorb energy, but most spontaneous chemical reactions will release energy. They get warmer, all right? Sometimes they'll get colder or they'll absorb heat from the environment, all right? They emit light. Sometimes so much energy will occur that they will explode, okay? And it might not be an explosion, all right? It might just be a small temperature change. For example, when metal rusts, it produces heat. But usually metal rusts so slowly that you don't notice the heat. If you had like little laser guns, you might notice it, but normally you don't. Okay? So evidence 2, energy is released or sometimes absorbed. Okay? Now, I want to be clear about this. Another common misconception. When I mean that something gets warmer, I mean that it gets warmer on its own. So let's take this example right here, okay? This is sulfuric acid being added to sugar. Now already I'm seeing a color change. Clear liquid, white crystals, turns black. That could be a chemical reaction. Oh, liquid's being created as well. But watch this. Bam, look at that. It's getting so hot that it's actually boiling the water there. Okay? So room temperature liquid, room temperature sugar, mix it together, and it gets so hot that it boils. So clearly that is producing its own heat. On the other hand, boiling water, this is not a chemical reaction. You're saying, oh, it's getting hot. It's getting hot because it's on a stove. So when I say that there's a change in energy, that a substance either gets hotter or sometimes gets colder, I mean on its own without you directly adding or subtracting heat energy from it. Okay, the last piece of evidence of a chemical reaction is this. It's hard to undo. Most chemical reactions go one way, or if they do go back and forth, they tend to settle in one direction, okay? And the reason, as I said, atoms try and get into more stable bonds, more stable arrangements. So once they get there, once they release all their excess energy, that's it. They're going to stick around there, all right? It's just like burning a piece of paper is like flicking over a big set of dominoes, okay? Once those dominoes fall and release their little energy, make their little clackety sound, they're not going to spontaneously stand back up again. And once the energy is released from this burning paper and you produce the products there, they're not going to spontaneously turn into paper again. So evidence 3, it's hard to undo. So once again, it is, if new properties appear like color, taste, smell, okay, if it releases or sometimes absorbs energy, light, heat, so forth. And lastly, it's hard to undo. These are all evidence of a chemical reaction. So check this out. making toast. Is it a chemical reaction? Yes or no? Pause the video. Hey there, Mr. Gucci back again. It's a chemical reaction. You started with white bread. You put it in the toaster. New colors, new smells, new tastes. The bread gets harder. You can't undo it. That's 5 pieces of evidence right there. All right? Now, Mr. Gucci, I didn't absorb or release any energy. Well, whatever. Okay, you got 5 more pieces of evidence. That's good enough. Okay? How about this? Cooking eggs. Take a moment. Is this a chemical reaction, yes or no? It is a chemical reaction, all right? I don't know how many of you guys have gone full Rocky and just drank some raw eggs, okay? But they're nasty, whereas cooked eggs are great, all right? They have a different color. They have a different taste. They have a different smell, okay? You can't uncook eggs, guys, okay? That's 4 pieces of evidence that cooking eggs is a chemical reaction. All right, how about this? Last one. Yes or no? Putting cream into your coffee, is it a chemical reaction or no? The answer is no, guys. No. Coffee is dark brown and it tastes like coffee. Cream is opaque white. It tastes like cream. Mix them together, what do you get? You get something that's kind of light brown, sort of opaque, tastes a little bit like coffee, a little bit like cream, okay? You put them together, you're not making any new flavors or smells, you're just melding, making a mixture of the flavors and smells that are already there. Okay, now if you put cream in your coffee and all of a sudden it tasted like banana, then you probably got some kind of weirdo chemical reaction occurring. All right, it also doesn't release any energy. All right, the coffee was hot beforehand. You put cream in it. It's somewhere in between the temperature of the coffee and the cream. If you have cold iced coffee and cream, put them together, it's still going to be cold. All right, no energy is released or absorbed here. Now you might say, Mr. Gucci, but it's hard to undo. You can't unmix coffee and cream. Yeah, okay. But that's 1 piece of evidence, okay? This is why I want you to look for 2 or 3 pieces of evidence, all right? Now, there are some common misconceptions. Pieces, things that you might think are a chemical reaction, but are clearly, well, not clearly. They're not, all right? So here we go. Physical change is any change that you make to a substance that doesn't actually change how the individual atoms are bonded together. So things like grinding, blending, crushing things, these are all physical changes, all right? You crush chalk, a piece of chalk, it's just chalk powder. It's the same stuff. It's chalky, it's white, tastes like chalk. All right? You make a blend of spices like this upper video here is doing, and you know what? It tastes like all the spices you put in there. Once again, if you do a mixture of, cumin, cinnamon, pepper, and salt, it's not going to come out tasting like strawberry shortcake, okay? It's going to taste like the stuff you put in. So the physical properties are staying the same, all right? Now, there are some common changes that you might think are a chemical reaction but actually aren't. They're physical. The 2 most common mistakes people make in identifying a chemical reaction. First of all, dissolving. When you dissolve something, not a chemical reaction. It's not. All right? First of all, because most of the properties don't change. If you mix sugar into water, you know what you get? You get sugary water. You get sweet water. It tastes like the water and the sugar put together. All right? You mix salt into water and it dissolves, you don't see the salt anymore. But you know what that water tastes like? Salt water. Okay, go take a swim in the ocean. Take a drink. Tell me what you think. Okay? And the other thing is, you can get that stuff back. It's not impossible to get back something you've dissolved. In fact, this is how they make rock candy. All right? They super concentrate a solution of sugar in water. They just keep dissolving sugar into water till it can't dissolve anymore. And then they let the water evaporate. And as it evaporates, that dissolved sugar has nowhere else to go, no place to hide. And so it comes back out again. Same thing with salt. If you ever bought sea salt, like fancy Himalayan sea salt or whatever at the store, they just take ocean water and evaporate it. Evaporate the water and the salt is left. So dissolving, not a chemical reaction. Phase changes. If something just melts or boils or freezes, if it goes in between the states, that is not a chemical reaction. All right? Most of all, if an ice cube melts, just pop it in the freezer again. Bam, it's ice. Oh, you boiled water, it's gone? Look at your window. There's little droplets there. Turn back into water. Okay? Phase changes aren't a chemical reaction because it's not changing what the particles are made of. It just changes how they move. All right? Solid particles, anything that's a solid, the particles are vibrating. Anything that's a liquid, the particles are sliding. Anything that's a gas, the particles are bouncing around. Okay? You haven't changed what it is. Ice is just H2O molecules vibrating. Water is H2O molecules sliding. All right? Gas is H2O molecules bouncing around. It's still H2O. So just changing something's state of matter by itself is not a chemical reaction.